Hello, everyone. Welcome to today's Tech Talk. If you are here, then you're in the right place. We will wait just a couple minutes. It always takes everybody a couple minutes to filter in, get Zoom hooked up, get everything connected, and then we'll go ahead and get started. All right, I'm going to give it one more minute, and then I'm going to assume that everyone who's going to be here is here. Always muted when I'm trying to talk. Well, welcome everybody to PDX Code Guild Tech Talks. I'm Merritt. I'm an instructor here at PDX Code Guild. I'm coming to you live from the brand new PDX Code Guild headquarters. It's pretty empty right now for obvious reasons. Everyone's remote. We're going to we're going to talk about a couple of things today. First, we said in the description of the event and everything that this is about some intermediate Git stuff, about what makes Git cool and about some different more intermediate things you can do in Git. And I'm going to assume that you've already used Git a little bit before, that the idea of using Git isn't totally new. So the first thing I'm going to do is talk a little bit about the history of Git and go over some of the basics, some of those things just super quickly that you've probably already seen. After that, I'm going to dive a little bit more into the command line and some ways, both in the command line and in GitHub, how we can check things, how we can take a look at things, compare things, see what happened, check some statuses, stuff like that. Ways that we can get a better idea of what we're doing in Git. And then we're going to talk about the big thing, which is branches. We're going to talk about why to use branches and how to use branches. And then we will finish off with GitHub. We'll talk a little bit about some different some GitHub features. And finally, just a little bit about how to fix things, how to use a couple of different things to fix things if everything goes horribly wrong. And then after that, I've got a couple of examples lined up so we can see 2 examples of that entire kind of workflow in action. And then hopefully, depending on how much time we have at the end, we'll see if we have time for any questions. All right, so let's go ahead and get started. So why Git? What's the point? Why are we here? Git is, these days, probably the most used, what's called a version control system, or a VCS. The idea behind a version control system is that it can keep track of changes that people make to text. Usually this is used for programming, for things that are in programming languages, but really it works in any format where there's text, where you're editing text files. So the reason why Git came into being actually dates back to, I don't remember when, I think the late 90s. I think it's sometime in the 90s, if not the 90s, sometime in the early 2000s, with Linux actually. People would work on the Linux operating system kernel. And as an open source project, Linux has always been a distributed project, a remote first project worked on by people that are distributed across the globe, working at different times, working on different things. And it takes a lot of work to integrate that. Think of, I'm sure many of you have seen the jokes on the internet where you have like final version .doc and final version 2 .doc and real final version .doc and like real final version .doc, things like that. That is a very primitive form of version control that most of us have used at one point or another. But the reason why we'd want to use a combined version control system is for 3 important reasons. One is security. Lots and lots of work goes into building a software project. Lots and lots of man hours, person hours go into writing all that code and getting everything running. And we want to make sure that the right people have the right access to the to our code. So we can limit it by some people can read it, some people can write it, some people can have total control over the project, over the code base. Another is history. This eliminates that real final sort of thing by ensuring that we only have one particular, that we can have one particular copy of the code base instead of having different copies that we have to keep track of. We can just have one copy, but that one copy remembers its own history. It remembers not just what's there, but a list of every change that everyone's ever made to it. At the same time, it'll remember just those changes from the past and the changes from the past that led to where it is now. It isn't like when you do something like final.doc, real final.doc, real final.doc, where you have everything just multiplied out there, where you're repeating yourself multiple times and you're having to store different copies of the entire code base. It'll remember the entire code base and then just all of the changes that have happened. And the most important is collaboration. Without any sort of version control system, you would have to do a lot of, to keep track of all this stuff, you would have to do a lot of sending files back and forth. you'd have to have a central place on the internet where you held the code base of a coding project, and you'd have to go ahead and copy over those files. And whenever anybody edited one, they'd have to copy over and kind of edit it to make sure that they slip it in the right place, in the right way. And that takes a lot of time, and it's very, very error prone. So using Git, multiple people can work on the same code base, make changes, and then push their changes up, and everything will, for the most part, just work. Every once in a while you get conflicts, but if you're following best practices, if you're doing everything right, it usually works out pretty well. So those are that is the why to use Git. We've talked about this idea of we have the code base, right? And we need to put that someplace on the internet. With Git, we call that a repository for our code. A bank has a repository. The school district has a book repository. We have a repository for our code. And often it lives in multiple places. For example, many of you have probably done something already where you have a copy of the repository locally on your computer and a copy of the repository remotely on GitHub's computer. And these repositories are made up of commits. So to see some stuff about a commit, let's go ahead and take a look at an example I have here. Whoops, that's not the right one. All right, I have a repository here on GitHub that I am going to be using for this presentation, just to go ahead and use it as an example. We can do things to it. It's a Django site. It's actually a boilerplate for an assignment for the boot camp. And I'm going to go ahead and right now it just exists on the internet. Because I don't have it saved anywhere locally because I deleted the local copy. So I'll go ahead and copy it back on down. And then we'll take a look at it again and look at exactly what's going on. So I'm going to go to my projects folder where I keep everything. And I'm going to use my first Git command, which is git clone. Most of you should have probably used this one before. This is how you get things down from the internet onto your own computer. So from my GitHub repository that already exists, I'm going to go to this green code button and copy this URL. Now I can go back to my terminal and I can do git clone and I can paste in that link and I can hit enter, and I now have that that folder, that DRF example folder, and I can go ahead and CD into it. All right, so now we are in a GitHub repository. So there are a number of different things I can use. We're gonna, one that you've probably used before is git status. Git status tells you where you are and what everything looks like. So right now it's giving me kind of the most basic message that it can give, that I'm on the master branch, that I'm up to date, and that there's nothing to keep track of. There's nothing to worry about. So let's change that. Let's real quick, again, I'm not going to go into depth about this basic stuff, but let's review just how to do a super basic Git workflow. Let's go ahead and commit something. So I'm going to type in code doc to go ahead and open this folder up in VS Code, which is my text editor of choice. And let's create a new folder or a new file, and let's call it hello.txt. Whoops, txt. And now let's say hello from Git. Alrighty, now let's go back to our terminal and let's do git status again. And we can see that now there is an untracked file. So an untracked file means that this is a list of all of the changes we've made. And putting things on GitHub is a 3-step process that's kind of like sending a letter. So the first step we have to do is you can think of each commit, each snapshot in time as an envelope. We have to put things in the envelope. So I'm going to go ahead and do git add. And right now, I'm just going to do capital A to add everything. And if I go to git status, you can see that there is a new file. There's a change to be committed. So we added all the changes to our commit. We added all the papers to the envelope. Let's go ahead and seal off that envelope. Let's finalize the changes that we're going to make. So I'm going to do git commit-m, and I'm going to type in a message. Whoops. Let's try that again. I must have missed the end quote there. There we go. Now, let's go ahead and send that letter. Let's send those changes up to GitHub. So I'll go ahead and do git push. I will go back over to my web browser and I'll refresh and look. There's my commit message and there is my file, hello from Git. So that all should be pretty, that's pretty basic, and that should already be familiar to you. That's kind of the basic flow of copying down a repository, putting stuff in it, and then sending things up. So let's talk a bit about branches now. So right now, we're putting everything in one place. Everybody's putting everything in one place. But that can be kind of tricky. What if we try to, what if we come in later and we're like, well, I don't want the exclamation mark, because that sounds a little too happy, a little too upbeat. Let's put a period in instead. And the same thing, git add, git commit-m. And now we can see that it changes to a period. But what if someone else is working on this file? Also, a lot of you have probably run across a thing where if you're working on one thing and someone else is working on the other thing, on another thing, and you try to commit something, and you get a message that someone else has already committed, and so the changes cannot be pulled. This happens, for instance, if I edit this thing right here, and I make it a question mark. So someone, let's say that this isn't me, let's say it's my alter ego. And I go to actually go ahead and, create another file. So we'll call this one goodbye.txt. And I'm going to say goodbye from Git. Okay, well, that was easy enough. Let's go ahead and add that on. Let's commit it. And let's go ahead and push it. And we get a problem. We get a problem that we can't push because the version on the web, the GitHub version, has changes that other people have made that we haven't pulled down yet. This means that we can't push our changes up until we make sure that our site is integrated with everything else. This means that if you have multiple people working on a project, you can't have multiple people pushing code up unless each person is making sure that everything is integrated each time. This has a very high chance of getting messed up. So we're going to use something called branches instead. We're going to take the history of our Git project, and we're literally going to turn it into a tree with branches. There is a cool thing in GitHub. If I go to settings and I go to, oh no, it's in insights, sorry, and go to network, it'll show me the network of all the commits. And right now you could ignore this one that says Dependabot, but notice that the rest of these are, all the ones I've made are just in a row. They are all just in one row. Our tree just has one branch right now. But it would be nice if someone could keep working on one thing and we could work on another thing without having these sorts of conflicts. So instead of this, instead of trying to commit this, let's go ahead and let's actually, instead of committing to master, I'm going to undo that. I'm going to say git, well, actually, we'll get to that in a minute, but I'm going to create a new, what's called a new branch. The keyword for that is just git branch. So I'm going to do git branch. And there are a lot of guidelines for how to name branches. But one of the simplest is to name what it is. Is it a feature? Is it a bug? Is it a patch? And then a dash, and then the name of it. Sometimes if you're lazy, people will just name branches after themselves. Then you have, you could have a Merritt branch, you could have a Pete branch, you could have an Austin branch, and everyone just kind of works on that. That's kind of the lazy way of doing it, but we can do it kind of the right way now. So let's say git branch feature dash goodbye dash message. All right, so I'm going to do one thing real quick, and I am, if I do a git status, I created the branch, but I'm not on the branch. You can see that it's still, whoops, where'd my mouse go? It's still on the branch master. So what I'm going to do is I'm going to do a git reset real quick. We're going to talk more about git reset later, but I'm going to do a git reset real quick. And that'll just make sure that right now those changes that we made to master that were kind of conflicting with everything that was on GitHub and everything, we're going to go ahead and reset those. So now if I do a git status, we're up to date. But if we go to our new branch, which is going to be git checkout. So if your git branch always sounds like that's the one that you would use to go ahead and view a branch, but it's for creating a branch. If you want to change to a different branch, think about it as you're going to check out a branch. You're going to check out that branch. You're going to take a look at it. So I'm going to do git checkout, And then I'm going to do feature. Does it tab complete? Oh, it does tab complete. Awesome. So I'm going to go to feature goodbye message. And you might have noticed, if you had really quick eyes, that my file tree here in VS Code changed. If I go back to git checkout master, you'll notice it changes again. That is because I took that goodbye file and I moved it over to my goodbye message branch. So it doesn't exist in the master branch. But it does exist in, again, that goodbye feature message branch. If you are using a command line, it depends. It's slightly different depending on what command line, whether you're using Windows or Mac or Linux, or whether you're using Git Bash or something like iTerm, or whether you're using the built-in terminal in something like VS Code. It depends on what exactly it'll say, but most command lines will actually give you a way, kind of like I do right up here, to actually tell you what branch you're on, which is really handy just for being able to look at it at a glance and tell. So that is our branch. So we can create a branch with git branch. We can switch between branches with git checkout. And now that we have two different branches, if I do a git status on this one, you'll notice that it says nothing to commit, working tree clean, but it has one more commit than the other one does. So now I can do git push, and I need to do git push. Because it's not just master now, I need to actually spell it out. I need to say git push origin and feature goodbye message.
I think you just got a typo in origin.
Yeah, I got a typo in there. That happens all the time. I'm surprised we made it origin. I'm surprised we made it 25 minutes in without me making a typo yet. All right, so both of those are synced up. Notice we didn't have any problems there. So let me refresh this, and you'll see that the graph looks a little bit different. We've split off into two branches. We still have the master branch, but we also have feature goodbye message, which split off right here. So now these two branches have two different things. This one has the updated hello text, and this one has the different goodbye message. And we can see that if we go over to code and go, we can see the different branches. Right now, I'm in master, and you can see that there is no goodbye message, and the hello has a question mark. Whereas if I go to the goodbye message, there is a goodbye, and the hello still has the period from earlier. So multiple people can make multiple changes, and those multiple changes can exist independently of each other. Now, instead of everyone needing to every time you commit and push, everyone on the project needing to make sure that their changes integrate with everything, you can do as much as you want, and it will all exist just on that branch. Everyone can work on their own branch without worrying about messing up the master branch or conflicting with anybody else's code. So we can keep going. We can, add more to our message here. GitHub is good too. And we'll do the same thing. We are in our feature goodbye message branch. So let's go ahead and git add. Let's get commit. And let's go ahead and git push. Whoops. Again, if it's not the master branch, you can't just do git push. Git push is a shortcut for git push origin master, but if you're not on origin and master, then it gets confused. We have to type it out manually. And again, you can use tab to automatically complete those long messages. So let's go ahead and do that. And now if we check the graph here, we can see that we've added another one. It's changed again. And we'll actually look at that in a minute. We could compare it. We could look at the two different ones. Let's see real quick. I'm looking over here before we move on, and we've kind of made a tree, right? We've branched things out. I made one branch, but you can imagine that if there were 10 people working on a project that had 20 different features and a bunch of bug fixes and everything, there would be many branches. And you can start to see how now each branch can have someone work on it without conflicting with the other branches. But real quick, I want to look over the chat because I know a couple of you had some questions. So the featured goodbye message isn't a file, that's the branch. So I had that goodbye .txt, and that was my that was the file that I created. That's the main difference between those two branches. Okay, and Mira says, I heard somewhere that when adding a commit messages, you should use present tense, like add updates rather than added updates, etc. Does this matter? Personally, I don't think it matters. It totally depends on when you're using Git professionally. You should, like most things with code formatting, you should follow whatever your boss tells you to. If your boss wants everything in present tense, then you should do present tense. You just kind of follow it doesn't matter so much what the system is, just as long as everyone's consistent about it. And this applies to most things. This applies to what you name your branches. This applies to how you do your commit messages. It even, things like linting in the code base itself. It's one of those things where as long as everybody agrees on what it should be and there's a uniform process, then it doesn't matter too much. So we have those different, we've seen those, insights. We've seen how we can branch things off there. We've seen how we can branch things off, but what about the master now? The master is different from our branch. It's easy enough to make a million branches. That's the easy part. But how do we make them come back together? That's where merging comes in. So what I'm going to do is I'm going to go ahead and merge the changes back into master. So I'm still on featured goodbye message. So I need to go back to the master. I need to check out the master again. And now what I'm going to do is I'm going to do a merge. So I'm going to say git merge, and I'm going to go ahead and give it the branch that I want to merge in. Notice that I'm merging into master. in master, and I'm going to merge in the feature branch from master. I'm going to go pull it in. If it sounds like you are, you're pulling it in instead of kind of pushing it, that's because when you do a git pull, that's actually doing a merge behind the scenes. When you do a git pull, it actually does what's called, I think it's a git fetch that downloads the files, and then it does a git merge to combine them together when you do a git pull in a repository. So that's why a git pull and a git merge they kind of have the same flow. You go to the place where you want it, and then you pull in from something else. So I'm in the master branch, and I'm going to pull in the changes on my finished feature goodbye message branch. So I'll do that, and it'll go ahead and import everything in. And if I go to hello, I have the, because I am in the master branch, I have hello from Git with a period, and I have the goodbye message in there now. If I go ahead and check out the feature goodbye message branch again, you notice that now nothing changes. We are all hooked up and good to go. So I'm going to go back to, I want to go ahead and push those changes. So I'm going to go ahead and do a git push. Remember, a merge, a pull is a merge, and a merge is also secretly a commit. Every time you merge, that's actually a commit. Oh, right. And again, I'm going to forget that I need to type in the origin and the feature goodbye message. And it's going to say that everything's up to date. Well, that makes no sense. I made changes, right? Why is everything up to date? That's because this is the goodbye feature message branch. We didn't change this. The one that we changed was our, was our master branch. And see, now it says your branch is ahead of origin master by 2 commits. That's the one we changed. Those 2 commits are the 2 commits from our feature branch that we brought in. So I'll go ahead and git push them. Again, this time I don't have to, oh, well, now we can just go ahead and do a git pull to make sure we have everything. It's going to bug me about this. I must have done something in why is there we go. I must have done something in a little bit of the wrong order because it asked me to kind of justify myself and why I wanted to make those changes. Again, we kind of did it the wrong way, right? I originally created it in master, and then we decided, oh no, we should really have a branch. So we kind of undid that and then went into the branch. So it's not a huge surprise that something's slightly out of order there. That's the whole reason that we're going to be using, that you would want to use branches in the future, is so that you don't get those kinds of messages, so that everything does line up. But now everything is, oh yeah, I need to go ahead and push everything again. And again, I only had to say git push because git push automatically changes itself to git push origin master. So I'm going to go back to GitHub, and now on my network graph, it's kind of hard to see with the arrows, but you can see that that branch went off, it had its own changes, and then it came back together. And now we have this commit that was keeping track of when we merged everything back in. All right, so that is the basics of branching. Branching can get much more complex. github.com. Let's look at a real life example of an open source project. Let's go to Insights and let's go to Network and let's look at their Git tree. It's still loading. This one's going to be a little more impressive than mine that just had the one branch. Whoops. So it's got a bunch of branches hanging out, but look, you can see here are different places where people have branched things off, made changes, and then introduced them back in. So in this case, they modified some HTML styling, and then they added that in. But they're not commits right here to master. They added that in, and then they recommitted it. And if we go back in time a little bit, I think there are some really fun looking, so you can see things like here where people made a number of commits and then they all joined up back into master. So you notice here that the basic flow, and you can kind of see an example again, like right here, is that everything's breaking off from master, making changes, and then merging back in. Best practice when you're working with other people on a code base in Git is that you should not ever commit to master. And if you, I know there are a couple of you in the audience that have taken my class before, and you're probably laughing because we only commit to master. That's because we haven't really been following best practice in that. But in a professional environment, you always want to commit to these feature branches for the reasons that we've looked at. Because keeping everything in its own branch like this, whether it's a patch branch or a feature branch or just a branch with your name on it, when you keep things in branches, then you can make whatever changes you want, and you can commit whatever changes you want, and you can push up whatever changes you want without conflicting with any other code. As we saw here, where we got that message when I tried to git push and it wanted me to git pull and everything first. If we have branches, we can go ahead and work on our own things. And then instead of having to worry about making sure that our code is integrated with all the code throughout, we only have to make sure that our code is integrated and works and is all synced up when we take our branch and merge it back into master. That's the only time we have to worry about it. We only have to worry about making sure our code slides back into the master branch when our code is finished, when our feature is finished. And if we don't finish it, if we just kind of leave it off to the side, then that's fine. It can just kind of sit there. But it gives us a lot more flexibility to be able to for multiple people to be able to work on different things without stepping on each other's toes. All right, so I want to talk about a couple more things. There are some fun things you can do in the command line. Most of them you've probably done a little bit in GitHub. You've probably done some of these things in GitHub, but sometimes it's super easy to be able to just do them on the command line too. You've all probably used git status, but there's another one that is really cool called Git Log. This tells you a log of all your commits. And here we can see all the different parts of a commit. Commit has a hash. So that's this alphanumeric unique identifier up here. That's just kind of an ID code, a unique ID code for each individual commit. It's got an author, so we know who to blame. It's got a timestamp. It's got a message, and then of course it's got the content, the content of the commit, which this one isn't actually showing, because this is just showing us a log of all the data. And it'll also tell us what is the head. The head is the current repository that we're on right now. It is this furthest out part right here. So this is the head. It's the furthest out part. It's where we are currently at right now. If we were to get into some, if we had more time and we went into some really trippy Git stuff, there's all kinds of things you can do in Git. It's almost a bottomless hole of getting into trouble. You can move your head around to different parts and different commits. You can even get into what's called a detached head state. You can work with things like rebasing to even change around the commit history and everything. Lots of different things that you can do in Git to really mess with things. But Git Log is a good counterpart to Git status. Git status tells you what's going on in your own little working in the head, but Git Log will give you a list of all of the commits that you've done. And of course, you could go to GitHub and look at GitHub, but it's nice to just be able to, with one command, just get a nice, easy list. Another is the diff command. Again, this is something that you can and probably have already done in GitHub, but sometimes it's nice to just be able to do it on the command line. So let's look at that. Let's do git diff, and it wants us to give it two different things. So it can take two different branches, two different commits.
Looks like we lost Merritt there. Hopefully he can get back to us soon.
Yep.
Whoops, I think my internet blipped out there. Let me go ahead and reshare my screen. And right back where we were. So this time I didn't accidentally copy and paste the word commit in there. And so it will give us something that says what we changed. So it went from goodbye from Git. GitHub is good too. We added that from this. I saw a question. It looks like my Zoom chat resetted, but when my internet went down for a second, but someone was asking. Oh, right. Yes, there is technically there are ways to delete a commit completely. If you really did want to, for example, like you said, if you pushed an API key or some other kind of sensitive information like that, but you should not rely on that. Even when you if you push something and then you go and try to change the commit history, that works great if you're working by yourself. But if other people are working with you, once you push something, if you go back and try to change history, it's kind of like Back to the Future. Does everybody remember Back to the Future when they go back in time and they start to change history, and then people's photos or the people's pictures start fading away in those photos? It's kind of like that when you start changing history. If you change history to things that you've already pushed and people have already pulled down, then you end up literally with people on multiple timelines, and it really does not go well. So you can commit things, but you can delete commits, but it's not a good idea. And for this particular example, it's actually moot anyway, because there are lots of things that are crawling GitHub out there and are looking for API keys, looking for other sensitive information like that, especially things like maybe AWS keys or any kind of like secret keys or things like that that actually let someone, do some damage. So what you should always do if you push an API key is just start over. Just go back to whatever API, whatever piece of sensitive information, whatever password. Create yourself a new one. Get rid of the old one. Just consider it compromised, because it is. It's once it gets pushed up, once a piece of sensitive information gets pushed up, it's compromised. So you just have to go ahead and create a new one. Yes, there is a standard practice to avoid this. There are a couple standard practices. We don't have time to go into them now, so you can look them up on your own. But you can use either environment variables, or you can create a secrets folder file and add it to your gitignore. All right. So I want to, since we only have, I promise we're going to keep it mostly within an hour. I want to go over a couple of things on GitHub and how we can use those to help us do this process. You notice probably that merges are a little awkward, but they're very important. Merges, the process of like going to it and then pulling in the changes and everything and then pushing it back up, is a bit of a weird process. And when you merge things in, that's the most important part of the process. That's when your code and the existing code all get combined into one. And it's good to be able to, what if you want to keep track of that? What if you want to comment it? What if you want to make it so that your boss has to check your code and make sure it's good and not just let it in? Because depending on how things are set up, for instance, some companies actually have things set up so that things automatically deploy live to the internet whenever something gets put in the master branch. Obviously, you don't just want to commit anything random to the master branch then. You want to have a process. And GitHub has something that is handy. I don't know why this is on my profile and not the DFR example. GitHub has a handy dandy feature that you can use to do merges. It's kind of like a merge, but GitHub has added a layer, and it's called a pull request. It's important to note that this is a GitHub feature. This is not a Git feature. This is a GitHub feature. This is on GitHub's website. This lets us use GitHub's website to make comments, check things, and then when we actually do the pull request, when it actually goes through, GitHub will do a git merge for us. So a git merge is a thing. A pull request is a GitHub thing that eventually does the basic Git thing. It's kind of, it's based on, it's going to do a merge, but it gives us more flexibility. So let's look at an example. Here on the, in this DRF example, we've just been adding like hello and goodbye messages, but let's look at a real live example. This is a very small Django project. So I'm going to go ahead and try to start up the virtual. We just downloaded it, or I just downloaded it an hour ago. So let's try to go ahead and set up all the dependencies and get it ready to go. Let's go ahead and do a pip-env install, and we're going to get an error. We got an error that Python 3.6 was not found on our system. This is not good. So I'm going to go up here and I'm going to file an issue. I am going to, I think it's behind, yeah, it was behind my face there. I'm going to hit the new issue button and I'm going to write an issue and I'm going to say, cannot pip-env install. Gives error that 3.6 not available. Hopefully, in a real life situation, you would be giving more informative messages than this. But for time, I'm just going to do this as a message. I'm going to go ahead and submit that as an issue. So now let's pretend that instead of Merritt the QA person or Merritt the junior developer, now let's pretend I'm Merritt the developer who's in charge of fixing this problem. So what I'm going to do is I'm going to go back to the command line. And I am going to do a git status and check that I am still in master. Good, I'm still in master. So I am going to create a new branch. And instead of feature, I'm going to call this one patch. I'm going to call this git, I'm going to call this patch, py version. And I'm going to go check it out. Now that we're on there, let's go ahead and fix it. Again, now we can go ahead and work on it, and we don't have to worry about what's going on in the master branch or anything. So I'm going to go to my pip file, and this says 3.6. I'm going to change it to 3.8. And I'm going to save it. And I'm going to do a git add. I'm going to do a git commit -m. Change Python version. And I'm going to do a git push origin patch py version. All right, so now if I go back to Safari, whoops, this shouldn't say pipping, this should say pip-env. I think that was the autocorrect getting me again. But if we go back to the DRF example and we look at the network again, shouldn't take long to load. It's a pretty simple graph. You can see that now we've got this little green branch sticking off here. So now, and if I go to the code, you can see that we've got a pip file in our master that still says 3.6. But we have the fixed version that's in the patch py version that says version 3.8. So let's go ahead and apply this change so that everything works. Now that I've got the new version, instead of doing a git merge and doing it like we did before, I'm going to do a pull request. I'm going to say, I'm going to go up to patch py version, and I'm going to do this button that says compare and pull request. So I'm going to check that these are right. I want to take my patch py version, and I want to apply those changes to the master branch. And I can go ahead and say what I did. So I can note that instead of just doing git merge and having no real control over it, this gives me a lot of control. So I'm going to say I changed the Python version from 3.6 to 3.8 to fix issue number 3. And I'll create the pull request. Notice that didn't merge it. That just created this thing that says I changed the Python version from 3.8, from 3.6 to 3.8 to fix issue number 3. And this also just gives a bunch of extra checks. Instead of just anyone just merging it in, we can do a bunch of things. We can make it so that someone has to review your code. Maybe your boss has to review your code before it can get merged in. You can label it, you can tie it to projects or milestones or issues. So we'll link it to that issue. And this gives the benefit, and also if there's anything that needs to get checked, if we need to make sure that the tests pass or anything like that, we can also do that here. Again, this is just an example. I don't really have any of that set up. I can also leave comments. I can say, looks good, other Merritt. And those get added to the conversation. I can go to commits and see what the changes are. And I can go to files changed and see exactly what got changed. And then when I am ready, I can go ahead and do this merge pull request button. And this is the magic button. This is the one that actually does that git merge command that we did earlier on the command line. So I'll go ahead and click that and confirm. And everything is merged and closed. And I think that issue even got closed. Let's go to, we can take a look at the issue as well. But everything got merged, and you can even delete the branch if you want. So here our issue is closed because I automatically linked the that branch to this issue, so that when we put the when we did the pull request, we automatically closed the issue as well, which is a nice little thing. And if I check the network graph here, whoops, that's the network graph from earlier. If I go up to Insights again, and again, go to the network, you can see that this patch PY version has once again been added to the master. So everything's all up to date and everything. So last thing that we're going to talk about today, I'm going to go ahead and run through it one more time. There is one more, just to give another example, there's another issue here. This db.sqlite 3, if I go to here, there are admin credentials here for a built-in user. But I'm pretty sure this DB SQLite 3, I don't think ViewRAW isn't going to get us anything useful. But if I remember correctly, this database does not have any users in it. Whoops, that was the wrong button. If I go to user, oh no, maybe there is a user in here, huh? I thought there was no user in there. Well, let's pretend there isn't. Let's pretend there isn't, and let's go ahead and add another user. So now that everything's been updated, I'm going to go to here, and I'm going to go ahead and check out the master. Now that we've made that patch, now that we've fixed everything, I can go to the master and I can do pip env install again. And, oh, whoops, I forgot to do a git pull. We got to pull all those changes because we didn't do the merge here. GitHub did the merge. So we've got to pull in that merge from GitHub because we didn't do it here. We did it on the second copy, on GitHub's copy. So instead of doing it here and then making sure it gets sent to GitHub, we did it on GitHub. So we need to make sure it gets sent here. But now I can go ahead and do that pip env install that I've been trying to do. And it all works this time. Perfect. So again, I know that we're a little over time, but I'm going to go ahead and show off that flow one more time of creating a branch, making changes, and then doing a pull request to make sure that everything's good to go, and then merge it back in. And then I'll have time for a couple of questions if anyone has any questions. So let's go ahead and create that that admin user. Or I think there already was an admin user. So let's go ahead and just create a user for me. I am going to I'm going to go ahead and check out, oh, I need a new branch. I'm going to call this one patch Merritt user. And again, I need to check out that branch. When we do branch, it just creates that branch. It doesn't put us in there automatically. So I'm going to go ahead and do git checkout and do the patch Merritt user. And now let's go ahead and create that user. I'm going to go ahead and do, this is a Django command. I'm going to do python manage.py create super user. And whoops, let's go ahead and do the migration real quick. I don't know what it wants me to migrate, but okay. Let's go ahead and do what we were just doing. Let's create the super user. This one I'm going to call Merritt, and let's do Merritt at pdxcodeguild.com. And my password is going to be test1234, test1234, and we're going to get a message that it's too common, but we're going to go ahead and do it anyway. And it created it successfully. So I edited the database and everything, and I did another migration. So there's some changes. If I do a git status, I can see that these two things got changed on my patch -Merritt-user branch. So what I'm going to do is I'm going to go ahead and commit them, add them. Again, I'm going to commit them. In real life, you wouldn't end up with a database committed to GitHub. But again, it's just an example. It's a good way to see how we can edit something and then in a branch and then bring it back together. And I'll go ahead and do a git push. Whoops, git push origin and patch Merritt user. All right, so we can see once again that we've created a new branch here. Let's go ahead and, like these other branches, let's go ahead and integrate them back into master. So again, I'm going to go to my list of branches, and I'm going to pick the patch Merritt user, and I'm going to hit compare and pull request. I'm going to confirm that I'm merging from the patch into master. I can enter a comment if I want, and I can hit create pull request. After that, anyone in, say, the company, for instance, can look at what commits were there, can look at what files got changed. They can make comments. Depending on how things are laid out, it might require tests. It might require people to review it. I might tie it to issues or milestones. There might be something out there, but I don't really need to worry about that. I'm just going to merge my own pull request. And when I hit confirm merge, that's when the actual git merge patch Merritt user happens. That's when that actual merge happens. Instead of us typing it in, GitHub is going to type it in for us. So that happened. Everything is up to date. Once again, we can go over to the insights and we can look at the network and we can see how, for a third time, everything is all nice and merged back in. So now, remember, because we did, usually if you do things in Git on your own computer, then you have to make sure you push and pull them to the second one, the remote that's on GitHub. But since that git merge actually happened on GitHub, I need to make sure I pull down those changes. So I'm gonna go back to the master using checkout, and then I'm gonna go ahead and do a git pull and bring everything in. And now we're good to go. All right. So hopefully you got a good sense there over the last hour or so about kind of a little bit more about why exactly we use Git, an explanation of what Git commits look like, what some of the different features we have for just for keeping track of the commits and looking at the commits, some of the different status things we have, like status obviously, but also like diff and log, and about branches, about why we use branches so that different people can work on different code and keep committing, keep pushing without having to keep integrating their code all the time. And also just keep the master branch clean, so it's a good working copy of everything in the code base that is finished. Again, most of the time in practice, your master branch is never actually committed directly to. And we can use things in GitHub like issues and pull requests to help us do some of those things. Pull requests in particular are just like a git merge, but they give us a little more functionality. They're more functionality wrapped outside of a git merge. All right, so that's everything we had for today. I'm sorry that it went a little long. Does anyone, I have time for a couple of questions if anyone has any questions. You can go ahead and you can say them, or you can type them up in the chat if you prefer.
I guess I was wondering if you have any like advice or resources for getting into open source contributions, because I just feel like it's such a daunting, like I tried to go and search by, you know, good for beginners tasks and they're just like insanely confusing and I don't know where to start.
Exactly. Yeah, no, that's a great question. There is, let me see if I can find it. I have, because I gave this to my students not too long ago, so I'm not sure where the link is or if I did a good job of saving it. But there's a good website for that's kind of a guide to oh yeah, it's called First Timers Only, firsttimersonly.com. That has different, wait, is this the one? Oh no, maybe this is the one I'm thinking of. There's a number of them. If you go to if you go to firsttimersonly.com, there's a number of different links there. I think it's, oh, that's what I was thinking of. Up for Grabs is a really good, that's linked to from this, this post. Up for Grabs is a really good site, just of an index of lots of contributions, lots of issues that are there waiting. And there's also a good one is that that very first link there, first contributions, that links to a GitHub repository. That one's great because it actually gives you all the steps about making a contribution. And the contribution is to edit this this repo. It's to edit this first contributions repo. And I think what you're supposed to do is basically add your name to it. You're supposed to add your name to it and then do a pull request and get your name integrated back. So it's another chance to, it's going to be the same exact process that we just went over. But it gives you an opportunity to, again, run through that once before you kind of go out there and start looking for real issues and everything to tackle.
Yeah, awesome. Thank you. That was like exactly what I was looking for. Something like that. Thanks.
Does anybody else have any questions?
Hi, Merritt. Hi from South America.
Hi.
Hi. Well, my question is if have you had the chance to use the new CLI of GitHub?
I have not. That only came out very recently, and I actually haven't had a chance. It looks very cool, though. So what Sebastian is talking about is that they just recently came out with a CLI for GitHub that, just like we've seen all these commands that we can do, the git merge, you know, git pull, git add, all these things. And then I made the distinction that those are all Git commands, but a lot of what's on GitHub is GitHub specific. It's GitHub specific things that behind the scenes do different Git commands. But for example, a pull request is a very fancy version of a git merge. Recently, in the last just couple weeks or so, GitHub released a CLI version, a command line interface tool, so that you can do these things like looking at issues, looking at pull requests, approving pull requests right from the command line without having to go to the website. So all those things that I did on the GitHub website, you can actually do through GitHub right on the command line. I haven't actually had a chance to really fool around with it yet, but it looks super cool.
Yeah, right.
And it's always nice to be able to do something right there in the command line and not have to break your concentration or go to a different web page or anything like that.
Yes, exactly. Looks good. Okay.
So yeah,
thanks.
I haven't had a chance, but it looks really cool. I'm excited to play around with that sometime soon.
Okay.
All right. Does anybody else have any questions? All right, then again, sorry we went over time a little bit, but thank you all for showing up, and have a good rest of your day.
Thank you for your time. Bye-bye.
Yeah,
Bye.
thanks. Have a good night.